Our world is basically built on these super complex systems, everything from the AI in our cars to our financial models. But here's the thing, they all break eventually. It's really not a question of if, but when. So the real question is, how do we design them so they fail safely and visibly, instead of just catastrophically? Let's get into it.
And this right here, this is a perfect example of the problem. You've got this incredibly sophisticated driving assistant, right? It's designed for safety, but it gets completely thrown off by a simple patched up road. The AI sees a wiggly line where there shouldn't be one, and it thinks the driver's being erratic. It might even try to correct the steering. It's a tiny failure that tells you a really big truth. These complex systems can get our messy real world so wrong.
So that really gets us to the heart of it, right? When the code has a bug, or the model is just plain flawed, or something completely unexpected happens, what's the game plan? Who, or I guess what, is actually in control?
All right, so here's how we're going to tackle this. First, we'll talk about why failure is pretty much inevitable. Then, we'll look at a system's first line of defense, automated systems. After that, we'll get into what happens when you have to call in the humans. And finally, we're going to zoom out and see how we can future-proof our world by applying these ideas to a huge global challenge.
Okay, so when a system starts to go haywire, its first reaction has to be automatic. It has to be fast. And the very first step is just noticing that something's off. And that brings us to this idea called drift detection. Just think of it like a system's ability to check in on itself. It has this baseline of what's supposed to be happening, and its job is to constantly ask, hey, am I still on track? Is what's happening out there in the real world matching up with what I thought would happen? When the answer is no, well, that's drift.
And wow, this is a fantastic real-world example of that. This chart from the European Central Bank shows economic projections. So see that yellow line? That was the forecast from back in September. But as new data started rolling in, the system spotted a drift. That blue line is the updated forecast from December. It's a course correction. It's this constant cycle of predicting, detecting the drift, and then adjusting.
Okay, so detecting a little drift is one thing. But what happens when the car isn't just swerving a bit? What if it's heading straight for a cliff? Or what if the economic model isn't just off by a tiny fraction, but it's predicting a complete meltdown? In those moments, you need something more than a gentle course correction. You need a big red stop button. And that, my friends, is where the kill switch comes in. It is exactly what it sounds like, a safety feature designed to just shut the whole thing down in an emergency. It's the system's last line of defense against doing something truly catastrophic. But, and this is a big but, it's also incredibly controversial. And this is where things get really tricky. On the one hand, you've got people arguing a kill switch could literally save lives. It could stop an impaired driver or end a dangerous car chase. But on the other hand, what about false positives? One person pointed out that a bad sensor or even a heavy snowstorm could trick the system, leaving a driver stranded and in even more danger. And what about your own autonomy? I mean, if you're in a real emergency, fleeing from a threat, do you really want your car to decide you're too scared to drive properly and just shut itself down? But let's be real, automated systems can't do everything. For those problems that are just too complex, too weird, too human for a machine to handle, you've got to call for backup. You need a human in the loop. Now, this isn't just, randomly yelling for help. It's a whole structured process called escalation management. And the goal is pretty simple. Get the right problem to the right person as fast as you can. You want the person with the exact skills needed to actually solve it. And it usually works kind of like a ladder. Tier 1, that's your front line. They handle the common stuff, the problems they have a playbook for. If they get stuck, they escalate it up to Tier 2. These are the specialists with more technical chops for the weird problems. And for the really high stakes, we've never seen this before kind of emergencies, that goes all the way up to Tier 3, the deep experts who can figure out what's truly broken. But here's the kicker. This ladder isn't a one-size-fits-all kind of deal. How severe an event is depends completely on the context. I mean, look at this example. A DNS server going down might just be a major problem for a regular company. But for an online store, that exact same event is critical because every second it's down, they're losing money. The system has to be tuned to what actually matters to the business. Okay, so we've talked about cars and businesses. Now, let's zoom way out. What happens if we take these exact same ideas, drift detection, kill switches, human escalation, and apply them to the most complex system of all, our planet? 1.1 degrees Celsius. According to the Intergovernmental Panel on Climate Change,
That's how much the global surface temperature went up between 2011 and 2020 compared to before the Industrial Revolution. It's just a number, but it represents a massive, massive deviation from our planet's baseline.
So if we're using the language we've been talking about, this is our planet's drift detection alarm. And it's not just beeping, it's blaring. The IPCC makes it crystal clear. Every tiny fraction of a degree of warming doesn't just add one risk, it makes multiple overlapping dangers worse, all at the same time.
So how do we respond? Well, using our framework, you could say mitigation is like our global kill switch. It's the drastic, all-hands-on-deck action. Deep, fast cuts in emissions to stop the problem from getting any worse. And at the same time, adaptation is our escalation process. That's how we adjust to the warming that's already locked in, trying to manage the consequences and lessen the harm. So what's the big takeaway here? It doesn't matter if you're building an AI or trying to manage a planet. The principles for handling failure are pretty much the same. We have to make failures visible, never hide them. We need systems that can actually refuse to do something unsafe and that can fail gracefully, in pieces, instead of the whole thing collapsing at once. We absolutely must keep a human in the loop. And through it all, the most important thing is to maintain trust by being honest and clear when things go wrong. Now, this next quote is pretty intense, but it really cuts to the heart of this tension we have between safety and freedom. Do we want systems that just take control for our own good? Or do we value our autonomy, even if it means we have to accept a little more risk? And that really leaves us with the big question, doesn't it? As we keep handing over more and more of our world to these automated systems, our cars, our economy, our climate responses, who ultimately gets to make the final call when it all goes sideways? The machine that's been designed for perfect safety, or the human who actually has to live with the consequences? It's a question I think we all need to start thinking about.